Good morning, good afternoon, good evening to everyone. I'm Robert Kennedy. I am a remote sensing scientist in geography at Oregon State University. I've been working on degradation and regrowth forever, it feels like, from a research mode, and have recently really been trying to get into an applied mode to try and help things. So I'm excited to be here. I'm co-lead of a GFOI theme on degradation and regrowth with Marieke Sandker, who is an FAO officer supporting countries to report emissions and removals. Marieke will be joining us in about a half an hour. So we're excited to discuss monitoring of degradation and regrowth. We're really excited. So many people registered. So many people are here with us today. Thank you all. Feel free to introduce yourself in the chat. If you later on want to speak during our discussion period, just raise your hand. We'll have to unmute you from this side. Let's see. Let's do a few housekeeping items. So this meeting is being recorded. We really are hoping that you can engage. So we're going to have some interactive polls here in a second. Also, please feel free to use the chat. The agenda, which we'll introduce in just a second, will be short presentations by our esteemed panelists, followed by some brief time after each one for Q&A, as well as a few interactive polls after groups of talks. And then after the four presentations, we'll have a discussion period. So we encourage you to leave questions in the Q&A chat, and our presenters, our presenters here will be monitoring those. They can answer questions on the fly during the talk, or we'll keep some for the discussion, excuse me, as appropriate. And just as a note, this is part of a larger effort related to this document that you're seeing here on the right, the methods and guidance document, to continually make this better. So we're looking for your feedback to help with that process. So we do have wonderful speakers here. We do want to, before that, know who's in the room. So let's start with that, and then I'll talk about the agenda in a second. So let's see, Daniela, I think this is our first test about doing the interactive polls. Do I need to stop sharing and give it to you? Okay, I will do that. Okay, so if you haven't used Slido before, and I'm not an expert either, but you can use that link over there on the left. And in theory, you should see that question in front of you. So we're interested in what kind of organization you represent. And go ahead and give you a little bit of time to get logged in. And this is for all of us to just get a sense of who else is on the call, who else is interested in this kind of material. Thank you. I always feel like this is a little bit of a race. Okay. Well, I think we have what, 29? Is that the number on the top, Madison? The number of respondents? Okay. We'll give folks a little bit longer, but as you can see, presenters, we have a pretty even mix of academic and UN International Organization folks, as well as scattering of other folks, um, which, not that you can change your talk now, but this will give you an idea of who you are talking to. Okay, interesting. Well, thank you all for being here and taking part in this one. We have one more. Maybe Daniela, we can go to the next one. What part of the world are you working in? And you can interpret this however you would like, if you're working in multiple places, etc. But Wow, this is great. We're feeling very international. Thank you all. Africa, Latin America, Europe, Asia Pacific, all pretty evenly represented, really. Excellent. Okay, let's move on to the next one. I see we've got almost 50 responses here. This gets a little more specific, and if you don't know the answer to this, that's fine. But we're asking about the biggest challenge in assessing degradation or regrowth in your country or your study area, if you don't work at a country level. Interesting. Thank you, everyone. Activity data. It's quite helpful, actually. And it looks like we have some comments in the chat. If you have additional comments that you'd like to clarify on this, feel free to, put those in the chat. We're somewhat limited in our ability on the Slido to have open-ended questions, a little bit of that. Okay. And we should have one last question here, right, Daniela, about the methods and guidance document?
I think we don't. So this question has been pushed towards the end of the presentation. So for everybody wanting to answer questions related to MGD and the MGD, please stay in tune until the end of the session.
Okay. Okay. Excellent. Okay. Well, thank you, everyone. This is great. This certainly helps me understand a little bit of who you are. And again, thank you all for joining. We now have close to 100 participants, which is really fantastic. So thanks. Hopefully we can do you right. I think we will. We have some excellent speakers. Let me just go back to sharing my screen. I can just show you briefly how we're going to do this. And so first, we have a couple of research presentations. So Viola Heinrich and Jingjing Liang from GFZ Helmholtz Centre for Geoscience and Purdue University, respectively. Then we'll have a poll, and this will go for about 40 minutes, starting immediately soon. And then some presentations on reporting, so more of the applied side. So Till Neeff from FAO and Diego Jose Enciar Nunez from University of Valle de Guatemala and Manuel Custodio, Guatemala National Institute of Forests, INAB. And that will be about another half hour, and that will take us until 20 minutes after the next hour. And then we'll have a discussion with all presenters and questions from you. So that's where we're going. So we're going to have some interactive poll questions at the end of the next two talks, and I'm just going to plant these questions here in your head so you can be thinking about these. We really would like you to listen to them with intent if you can. Which topic is most relevant or interesting to your situation? In fact, it doesn't have to be just from the two talks, but if it triggers ideas, that's great. What would help you move towards acting on that topic if it's not something you're doing? And if you were to adopt a decision support system from, especially when you hear from Jingjing's talk, what form would that take? What kind of app is that? What would make it most accessible? So, without further ado, let's here. Let me go back and unshare my screen and introduce Viola Heinrich. I think, Viola, while I'm talking, you can try and share your screen and get ready to go. So Viola is a postdoctoral researcher at the GFZ Helmholtz Centre for Geosciences in Potsdam, Germany. She's a remote sensing scientist working specifically on mapping forest carbon dynamics, especially in secondary tropical forests. Let's take it away.
Ah, I lost the unmute button, but I found it now. I think you can hear me.
You're all good. Go ahead. Yes.
Yes, good. Thank you, Robert, for the introduction, and thank you everyone for joining. As Robert mentioned, I'm a postdoc. at the GFZ, and today I'll be actually talking to you about a review paper that started all the way back in March 23 when we hosted a workshop in Potsdam in March 24. And the idea of this paper came about to synthesize existing emission and removal factors that exist for tropical moist forest, coming specifically for degradation and regeneration. So we recently submitted this to Science Advances, so let's see how it goes. But I'm going to walk you through how our thinking in all of this, and hopefully you'll get some useful things out of this. So I'm just going to hide my video panel. There we go. So when it comes to thinking about how do we measure carbon losses and gains in tropical moist forests, I think this figure that I've made is probably quite familiar for you, but we can of course think of things that are happening in the tropics, such as deforestation, but also in degraded forest systems, we have things such as fire, selective logging, which are traditionally considered as degradation processes, but also we're moving towards, within an anthropogenic climate change, more an increase in wind throw and drought-driven disturbances. But of course, we can have recovery occurring within these degraded forests, and along the forest edges, we've got what's been commonly known as the forest edge effect, which is on the frontier with other systems in tropical forests, for example, other lands and other land uses. And of course, we also have the regrowth component in the form of secondary forests. And we can monitor and measure these things, for example, using small-scale systems in the undisturbed forests, such as terrestrial laser scanning, plot data, drone data, and increasingly, we can use airborne and space-based remote sensing data to monitor degraded forests and the emissions, or find, first of all, in the form of activity data, but also assessing the emissions from these systems. And of course, we can use spaceborne optical data to look at traditional sort of deforestation, but also start to look at secondary forests. In the seedling part, we often look at more smaller assessment methods, but increasingly we can also use satellite-based remote sensing. And as we move through time, I'm quite a young scientist, but we stand on the shoulders of many scientists that have come before us. And this is just a snapshot of some of the key studies that have emerged from the 1980s all the way going forward. And we've got more and more studies emerging. Now we're in the 2000s, 2010s, now we're in the 2016s, 2020s, and there's been an explosion of research really on looking at emissions and removals from in the tropical moist forest regions. And this was one that was actually published last Tuesday, led by the Nature Conservancy, for example, Nathaniel Robinson and Susan Cook-Patton. And this is just another example of the explosion of research that we've had. And there's many more to come, and these are just 3 examples. You'll hear from Jingjing Liang in a minute. And while all of these estimates are really driving research forward, at least from my perspective on the science side, they're really also creating confusion for application purposes. And so one of the key aims of this study was really to put all of these studies into context with one another, not just focusing on 1 or 2 studies, but really focusing on what do we have out there from peer-reviewed science. So to understand how these estimates from disparate data sources align, and consider how these estimates and methods could potentially be integrated into MRV thinking. And just to give you a little background into how we did this, we synthesized 115 studies, which were peer-reviewed in a time period of about 44 years. And we've extracted key variables, which you can see here on the right of your screen. One of these was crucially the study type. So this is what we use to distinguish between different data sources. For example, traditional field data integration, which is kind of the collective term for field data, where a study integrated a lot of field data sites, but also remote sensing and increasingly satellite data. We grouped our studies into 3 key regions. And then on the right here, I'm not sure if you can see my screen or my mouse, but on the right, we focused especially on absolute and percentage carbon losses and gains, as well as some of these other important variables that we extracted. So moving on to some of the results that we found basically a 60-fold difference in the carbon losses across different degradation types, which you can see here on your screen, coming from sort of low carbon deficit values to all the way to higher, 100%. And we expressed as a sort of a fraction or a percentage of carbon deficit compared to nearby undisturbed or prior forest state. And if I just focus on one, because this is quite a lot of information on one slide, I'm just going to focus on emissions from fire. So this is the relative, the percentage carbon loss. We can see that, especially within the American continent, we have a lot of studies estimating emissions from fire. And for some thinking about this could say, oh, there's a lot of data, it might cause confusion and not knowing which state data set to use when. But in other regions, such as in Africa, we actually really struggled to find a lot of studies. So we could say we have kind of too few data to really understand or say with certainty what are the emissions estimate due to fire. On the other hand, we can also say that we have just the right number of studies, especially in the American continent, to say that we can see a huge amount of variability. So a fire is not just a fire, as you all know, and results in different emissions. And so we looked at this in a bit more detail. And in the studies that actually, we split up the studies that looked at cumulative disturbances. So that's on the right of this little figure. And studies that just had single fire emissions in their study. And what we can see here by looking at the mean, the crossbar, we can see that there are clear differences in the carbon deficit compared in single versus cumulative disturbance events, whether that's multiple burnings, which you can see in green, or also some studies also looked at the impact of co-occurring disturbances such as fire compounding with selective logging. So one key takeaway from this is really, when possible, it's really important to consider cumulative and co-occurring disturbances for quantifying carbon or above ground carbon losses in this case. And what we've done is, the top right might be quite a familiar table for you. We've kind of tried to recreate the IPCC reporting of table 4.9 that you can see in the greenhouse in the good practice guidance. But this is very much just in the style of IPCC Tier 1 methodology, where we've created the third column. You can see the mean carbon losses expressed as a percentage for all of these different degradation types. And this is just a screenshot, so it keeps going for the different regions and also on a pan-tropical scale. So this is one key way that we could potentially synthesize research studies into this to create useful information as well going forward. Looking at the flip side, the carbon gains in recovering degraded forests. On the left, you can see the degraded forest. On the squeezed, on the right, you can see secondary forest regrowth. Overall, looking at the mean, which is the pink horizontal line, we can see lower regrowth rates in degraded forests compared to secondary forests, but the confidence intervals are really overlapping in this. If we plot the regression line onto this, where I've plotted the carbon deficit, which is what I've shown before on the x-axis, and the annual carbon increment on the y-axis, we can see almost some kind of correlation between faster carbon accumulation rates related to greater carbon deficits. I've put a question mark behind that because we have very few data points to really support this. And often in the case of these high emissions, high removals regions, these 4 points up here, they're also in the Asian continent, so it might also be a geographical difference that we're seeing. Zooming into just secondary forests, we can see there's large variation in the carbon gains across the secondary forest, which, as we know, reflects the regional regrowth rates and their complexity. And again, there's quite a strong bias towards kind of the Americas, but especially the Amazon. But we've used this to our advantage, and we've actually zoomed into 2 regions in the Brazilian Amazon, Pará and Manaus, to look at the differences between different data sources. And what we can see is that generally, all of the estimates, each of these data points, sits within the IPCC Tier 1 standard deviations and also within the greenhouse gas inventory boundaries. But we can see a lot of variations, and especially what stands out from my side as a remote sensing scientist is that estimates coming from satellite-derived estimates are generally lower than field site estimates, which is something as researchers we need to think about how these different data sources align or not. So moving to my final slide, I think there's been an explosion of research really into post-disturbance carbon fluxes from the degradation side, but also from the regeneration side. And we have potential to integrate this into policy, which is why this session today is so important. One key takeaway, which I've put in different colors, research or application, blue and orange, and where these are really relevant. We need to work towards identifying the drivers of degradation fully and considering the type, whether they've been cumulative disturbances, and consider the intensity of the disturbances, which I think is one of the first steps which will help us reduce variability in the estimates we see, but also the uncertainty. We've created these tier 1 style emission factors for degradation, which have the potential to be applied in a gain loss approach with activity data, or used for verification or comparison purposes with national data sets. I think we need to move towards integrating national forest inventory data with Earth observation data and really compare this, comparing removal estimates in a gain loss and stock change approach. And for the researchers, it's important to address this spatial bias that we see, specifically focusing on the Americas and the Amazon. And my final food for thought is that it's not just a matter of semantics. We really need to consider how we define degradation and regrowth, because this really has implications for MRV. And I'm wondering how we could come towards a common framework to address this. Thank you very much. And yeah, you'll hear more from me in the discussion, I guess.
Excellent. Thank you, Viola. That was great. That was a lot of information presented very quickly and really, really well and clearly. Thank you so much. Hopefully, we have some questions. Any clarification questions in the chat? Daniela, I guess maybe you're monitoring that.
Yes, no questions as of yet. But of course, if anybody has any questions, feel free to write them in the chat or put them in the Q&A box.
Do I get prerogative as a host to ask a question then? Is that how this works? So on your degradation slide, with so much variability in some of those different processes, what's your sense about it seems to me that there's so much variability that would be difficult to put that in a table. And I know that we need tables as a first cut, but how much is the challenge of looking at area of degradation times some degradation factor worse for degradation than deforestation, do you think, just because of that variability? I'm curious your thoughts on that.
Yeah, it's a good point. And I think we also provide kind of sub tables, which I didn't show, splitting up into where if we have cumulative disturbances, so that would help reduce that variability further. But I think, I mean, I'm speaking from a scientist, but maybe others in the call might disagree. At the moment, there is no kind of IPCC summary table in the good practice guidance. So I think this is kind of the first step. It will probably be outdated very soon, but I think it's kind of proposing the first step and how we could go about this. And as more and more research emerges, we can probably help reduce that variability and tease out the patterns a bit more as more data becomes available.
Excellent. Cool. Thank you. Yeah, that makes sense. You're right. I mean, we have to start somewhere for sure. Yeah, that's a very good point. Do we have maybe one other question in the chat? I'm looking at the agenda in terms of timing too, but Daniela?
Yes, we actually know there's quite a few questions in the Q&A.
Oh, no.
Thanks a lot.
I'm sorry. Okay.
But I think it's actually good, Viola. You can also keep answering them as the event continues, and you can type your answers. Maybe let's do one question from Naikoa Amuchasegi. He asks, is there a summary of approaches used to identifying the degradation stratum? Was it driver specific?
I need to read the question. Where is it? Okay. Yes, we had generally the definition of degradation was quite broad. We didn't want to limit ourselves to cutting out studies, but we generally we applied similar FAO IPCC definition of it has to stay remaining a forest, remaining forest, but reductions in the biomass as a result of this. So that was the kind of the overall approach that we used. We didn't limit ourselves, well, we did limit ourselves into those 5 categories that I showed, just as these are the key ones, especially selective logging and fire, but also increasing the edge effect, which are currently not included in a lot of reporting. So these were the ones that we wanted to highlight.
Excellent. Okay. Okay, thanks. Maybe we'll move on. Excuse me. So again, I just noticed there's also a Q&A icon, which I've not seen on Zoom before. So Viola, I think maybe you might want to look in both sections if you have a chance to answer some of those questions. And thanks to everyone for putting those in. If we have lingering questions that we can get to at the end, that will be we can use that last 15 minutes of discussion for that. So how about we switch on to our next wonderful presenter. It's my pleasure to introduce Jingjing Liang. So he's a forest ecologist and associate professor at Purdue University, leading and coordinating several global efforts in large-scale forest modeling and biodiversity research. He's the principal developer of the matrix model, which I believe we're going to hear about, and a Purdue University faculty scholar, which is awesome. Anyway, take it away.
Thank you very much, Robert, and thanks everyone for coming today. It's a great pleasure to present some of my new studies here. And first, I would like to see that this effort, the things about the matrix model that I'm going to present here is truly a team effort that involves efforts from lots of collaborators from around the world. I only put my name here only because we have not tallied basically all the collaborators yet, but as soon as we have the publication ready and submitted, and we are going to put everyone's name here and to acknowledge that. So back to my presentation. So we are going to change the gear a little bit and talk about how we can make use of the field data, namely forest inventory data, together with artificial intelligence, to strive for the accurate forest carbon change estimation for the greenhouse gas inventories. And I'm going to talk about the matrix model, so which is going to be an AI-based global forest growth model. So when we talk about the problems that we did early on today in the workshop, what are the most challenges that we are facing in greenhouse gas challenges? And I believe, to me, the answer is the uncertainty. So how can we reduce the uncertainty of all those aspects? That's one of the greatest challenges. So when we talk about estimating above ground biomass change rates, so here the keywords is change rates. It is a little bit different from just estimating the above ground biomass, but it's temporal change rates, which is even a greater challenge than estimating above ground biomass per se. So for many countries, if they do not have, for example, repeated forest inventory data and do not have other means, for example, the forest growth models locally made for those countries, and how are they going to estimate how much above ground biomass has changed in forest regrowth, or how forest recovers from fire or degradation or things like that. So one of the only means there for the globally is this IPCC Tier 1 table, so table 4.9, which basically outlines the average above ground biomass growth rate in ton per hectare per year, and then it gives you an average number and the uncertainty level and the references. So this is one of the key reference that many countries are using right now to estimate above ground biomass change rate. But how reliable is it? So in order to find out, we have collected a whole bunch of remeasured sample plots that are distributed from across North America. And when I say a whole bunch, it's actually over 378,000 remeasured plots that we collected. And so if you see the graph to the right, what we did is that we plotted the predicted number according to the IPCC, and then plot them against the observed number in the vertical axis. And then we do this for different ecoregions across the continent. And what we want to see, ideally, if IPCC table is accurate enough, we should have seen a trend line behind all those data points that is close to the 45-degree reference line here, which basically says the observed is equals to the predicted data. However, what we have found is actually another story. So the trend line behind all those data points is here outlined in this red broken line, straight line here. And it is nowhere close to the 45-degree reference line. It is actually has a negative slope, which basically says the trend, even behind the large trend behind the observed, it is nowhere close to the predicted lines, to the predicted trend according to IPCC. And if you see the R-square value, it's less than 0.01%, which basically says there is a huge level of uncertainty behind our current IPCC table 4.9 that we are using and some of the countries are actively using now. So what are the consequences? If you just compare the population, the mean at the plot level, okay, so the IPCC at the per plot level, the mean is about 1.73 ton per hectare per year. And then the observed number is higher than that, it's 2.1, although you can see it's just the number is close enough. However, if you put that into the global context, if we convert the per hectare into together based on those 752.7 million hectare forest area in North and Central America, we found that basically the estimated value according to IPCC is 53% lower, is 53% lower than what is actually observed there according to the repeated measured plots. And this bias is equivalent to missing 1 billion metric tons of CO2 absorption rate per year, and which is roughly about 13% of the total global net carbon sink. So what does this say is that if we are relying on the IPCC table and at a large scale, the bias could be so huge. Even for the continent of North America, it is worth about over 10% of the total global net carbon sink. So keep that in mind. The objectives of our project is to develop a model, which we call the matrix model, in order to accurately estimate the forest growth rate, including the carbon dynamic and the carbon change rate for the local management and policy making applications. And this model is going to be powered by AI and ground sourced data. So whenever a country has national forest inventory data, we are using that. But if NFI data is not available, we are using some other ground sourced data from private sources or from institutes that collected such data in addition to NFI. And we are also aimed to improve the removal factors suitable for inclusion in the EFDB tabular format. So this is the objective for our study. And in order to estimate all those different dynamic trend for over different ecoregions and biomes across the world, we have collected over 1.8 million sample plots from 92 countries. And all those plots include over 50,000 tree species and involves over 400 data contributors that are located from across the world. So the map here shows a location of all those forest inventory plots. And what you can see is that for each individual plot, we have the plot location in latitude and longitude, and we have the species name, and in terms of the binary, the Latin name, and we also have diameter breast height, and also the trees per hectare, which is the expansion rate that allow us to actually convert the single tree inventory or measurement rate to the whole population of the local forest. And then we have inventory years. And as a subset of this data, we have the remeasurement data. So we have year one, the DBH, and then after year one, that's after 5 or 6 or 7, 8, 9 years, then it will be the second inventory, and we have a new DBH data or the new status of that tree. And based on that, together with other type of input data, for example, the bioclimate data, the topography, the soil attributes, and anthropogenic influences, for example, the human footprints, we feed this through this AI-based platform called the matrix model, which basically estimates the dynamics of forest tree population by its 3 subcomponents, U, R, and M. Here, U represent upgrowth rate. Upgrowth basically represent how much diameter has grown from year 1 to year 2. And R represent recruitment or ingrowth. How many young trees have been recruited into the smallest DBH class, which we identified as 10 centimeters and above. So this is called recruitment. And then the other another key component is the mortality rate. So how much or what percentage of trees have died from year 1 to year 2, and by incorporating all those the rate of upgrowth, recruitment, and mortality, we were able to estimate how much population has changed and also how much above ground biomass or carbon has changed over time. And then if we do this by pixel by pixel and then put them together, we can map the whole continent and even the whole world. And in order to find out if this type of AI growth model is useful or not, we have benchmarked our model against 3 other models that have been widely used for the continent. So for the United States, we have compared our model against the Forest Vegetation Simulator, FVS, which is developed by the US Forest Service. And for Canada, we have compared our model against PICUS, which is a type of the Landis model, the landscape, basically forest dynamics model. And then for Mexico, because there is no nationwide large-scale forest growth model that for the country of Mexico, we were able to compare it against a regional model that's developed by a local biometrician in Mexico. And so what we have found is that what we did is that we are collecting this independent set of post-sample validation plots, which is over 10,000 validation plots in 3 countries. And we made sure that neither the matrix model or either of those benchmark models have used those training data in order to train those models to ensure independency and of all those validation plot data. And then we predicted the basal area of the entire plot at the time of the second inventory from the time of the first inventory, and then we compare them against the actual observed data, which is again in the horizontal axis. So horizontal axis observed, no, sorry, horizontal axis is the predicted value, and the vertical axis is the observed value. And then ideally, if the predicted is the same as the observed, you would see the trend line will be very close to this 45-degree reference line, which is shown here in the dotted line here on those plots. So what we have seen here for the comparison between matrix and FES is that the matrix model for the United States, the trend line, the predicted against observed data is very close, which is this blue solid line here is very close to the reference line. And however, in comparison, the FES is slightly off. And what we have found in terms of root mean square error, or MSE, the matrix model is 50% more accurate than the FES model. And for Canada, the PICOS models performed very poorly, unfortunately, and our model is very, on the other hand, is very close. The matrix model is very close to the 45-degree trend line. And for Mexico, both models, the locally made forest growth model as well as matrix, performed equally well. And the matrix model is slightly better, but there's practically no difference between those two types of models. So which means that when compare a matrix model against a locally tailored and a locally trained forest growth model, matrix model can perform equally or even slightly better, which is good news. So now we have shown that basically the matrix model works well for the continent of North America, and we have tentatively scaled it up to cover the entire forested region across the whole wide world. And basically here, this map here shows the dynamics of above ground biomass change rate, or DAGB, on a per year basis from year 2000 to year 2020. And you can see how those generally trend, how those subtle changes, how those subtle numbers change across the whole forested range across the whole world. And you can see, as expected, for example, the subtropical forest in East Asia, especially China and part of India, has very high above ground biomass change rate, and the similar thing happened to the forest in Australia as well as New Zealand. And also in the tropical forest, Amazonia has very high above ground biomass change rates. But however, on the other hand, we have seen that some of the regions, for example, the sporadic regions in the boreal forest in North America, in eastern part of Canada, as well as western part of Canada in British Columbia, also along the Rocky Mountains, we have seen some of the regions with a negative above ground biomass change rate, which is likely caused by those high frequency disturbances like forest fires and or a combination of other disturbances as well. And also in South America, we can also see that the regions is especially in the savanna areas, and so some of the regions also have a negative above ground biomass change rates, likely from the forest degradation and a combination of disturbances and other factors as well. And then the other thing I'd like to highlight is that because matrix model, it has quantified upgrowth rate, recruitment, and mortality. So at the same time, we can also decompose the above ground biomass change rate into those three key components: above ground upgrowth, recruitment, and mortality. We were able to see for any pixel, for any forested area across the world, what has contributed to change of above ground biomass. And so those are, having those maps outlined what is, which area is affected more by upgrowth or recruitment or mortality will help us understand how to best conserve and how to best restore the forest in local areas.
Jingjing?
And so,
Jingjing. Sorry,
yes.
this is Robert. We're a little bit over. Can you wrap up in like
Sure.
a minute or so, or okay?
Yes. So we are almost towards the end. So what we are trying to do, what we are trying to do next is that we are going to basically update the IPCC Tier 1 table using the results we have, and we'll have something similar, but something that is more accurate to the current forest inventory data. And then on the other hand, matrix model, we want to make this model not only useful for large-scale estimates of forest carbon dynamics, but also we want them to be useful for local forest management and conservation. For example, this here map this diagram basically shows that how matrix can help local landowner of the Pacific Northwest to manage their Douglas fir and western hemlock forest. And basically, we see that with a 10-year cutting cycle and partial harvesting regimes, and this landowner is going to lost lots of money, about $2,000 per acre, and which basically helps the land management make the decisions. So final slides. Yes, we have found that the matrix model is useful for global biomass change estimate, but also supports other areas like greenhouse gas reporting and credible carbon finance and things, and also promotes open scalable tools. And I want to thank our sponsors and the different sponsors listed here, especially FAO colleagues, Javier and Till and Marieke, and many colleagues who have been part of this incredible journey that we are on together. So this is only the beginning, and we are still in the process of refining the models for different areas of application. And your inputs will be greatly appreciated. And with that, thank you very much for your time.
Excellent, Jingjing. Thank you so much. That was great. I apologize. I was so engaged that I lost track of the time. We're actually quite a bit over, so I think maybe what we should do is, I think there were a lot of questions in the chat, so maybe you could take a look at some of those and we could answer those there to make up a little bit of time. Is that okay?
Sure.
Thank you. That was great. I have a bunch of questions that I'm gonna have to follow up with you afterwards too. Thank you. Okay, so then Marieke, I believe we're ready for you to jump in and do our interactive poll. Are you ready?
Totally ready, and apologies for arriving late. So as the poll question comes up, I might as well introduce myself. I think, Daniela, you're pulling them up, right? There we go. So my name is Marieke Sandker. I'm a forestry officer and coordinating MRV that the monitoring team is providing on emissions and removals from forests, mostly UNFCCC, but also carbon accounting. All right, so here we go. Back to you, which is more important. Everybody online. So which topic, and with that we can mean it's an idea, concept, a method, or results from these two talks are the most relevant or interesting for your situation? So the country that you are working in, the research area that you're working in, we'd really love to hear from you. Especially countries working on this topic. What do you want to know from these scientists? Emission factor database. Okay, great. MRV, more MRVs needed. Mapping degradation, yes. Estimating removals. Great. All right, our word cloud is forming. Uncertainty of above ground biomass and a change. A lot of emission factors, and some people want it in the emission factor database. Oh, well, there you go. Emission factors is the central theme here. The methodology. Nice. Let's give it a few more seconds. All right, I still see the number of people logging in, so let's give it a little bit more time. So here we go. So a lot of interest around mapping degradation, about emission factors, uncertainty. Yeah, uncertainty is a recurring theme here as well. Like biases. Excellent. Well, it keeps growing, so I feel bad moving to the next question. But we're also running out of time. So I think this is a great cloud. And I hope this is also excellent feedback for the two presenters. You know, this is what the crowds, this is what the people out there are really looking at. So hopefully some of the papers that you're going to publish soon will satisfy some of the questions from the audience, the topics that they're interested in. Okay, so I think we can move then to the next question. All right, so what would help you move toward acting on that topic? So what is the main constraint on your end? And this is again mostly for people working on the reporting countries. So here we go. We have technical capacity of staff, finance and other resources. Policy or rule change is not that important. Computing, so far not managed, not ticked. Oh yeah, well there we go, since I mentioned it. Okay, but the number one, okay, I think we can already clearly see two topics really standing out, which is the finance and other resources. I think that's a recurring one, right? And it's the technical capacity or staff to actually help. Of course, MRV is a big bone to chew on. So to get all of that, a lot of technical capacity is needed. All right.
Marieke, can I just jump in? And
Yeah, please.
if for any of these multiple choice questions, folks, if you'd like to elaborate in the chat, if there's more depth, that would be wonderful so that if there are specific examples, that could help.
Great. All right, I think we've come to a static percentage here. We have our top two. So I think we can move to the third question. All right, so if you were to adopt decision support system like the matrix model, what form or type of app is most useful or accessible to you? So would that be like a web interface? Would that be some kind of app-specific format like an Excel spreadsheet or a specific model software that you can run on your own computers? I guess there's also a bit of data sharing component in here. All right, so the web interface is winning it for now. Right, Jingjing. So this is, I guess, mostly interesting for you to see how can the matrix model be made accessible for countries, and how can they take advantage of that? Excellent, great. Okay, I think we got an idea on this one as well. So thank you everybody for contributing to these polls. I think we can now move on to the next presentation. And as we are moving on, at the end of the presentation, we'll be asking you again a few questions in the poll. So maybe you want to already consider some of these questions. So what we will be asking you after Till and Diego will be presenting is, which strategies or challenges have you encountered or observed in assessing degradation or emissions in your area of interest? We will ask you if your country or study area is using data from repeated ground measurements. Here we go. It's nice to have them on screen as well. On repeated ground measurements in reporting degradation and or regrowth in forest lands. And if yes, what are the challenges and successes you found? And if no, what changes would need to occur for you to be able to use repeated ground measurements? So keep these questions in mind as we are going to listen to the next presentation. So the next speaker is my colleague, Till Neeff. So Till is an FAO forestry officer, and he is also chief technical advisor of the UK-funded program Accelerating Innovative Monitoring for Forest, or shortly AIM for Forest. Till is a climate, finance and forest expert, forest policy expert, and he has recently published a paper on country assessments of degradation. So Till, over to you.
Thank you, Marieke. Thank you, Marieke, and thanks everyone, and grateful to be here and for the invitation to participate. Are the slides in the right way to project them?
Yeah, they look great.
All right, awesome. All right, so this is the presentation to speak about country approaches. The two previous presentations were really, they were very scientific. No, they were scientific for really some basic research that is going on. But here at the FAO, and I'm part of the FAO team, what we try to do is we try to build bridges. We try to build bridges between that kind of scientific work to the applications by countries of approaches to estimating emissions from removals and forest degradation. Marieke has already said that. We work with the generous funding of the United Kingdom under the AIM for Forest program, and we are very grateful to them. One more thing that I will add here is that really I'm the one to present these slides, but in reality, this is a joint venture between Marieke and I, who we both work on this together very closely. Okay, so it's just a bunch of slides to speak about what the countries are doing and how they leverage the methods and the approaches and all the science that goes into this for estimating emissions and removals from standing forests, which is really the same topic, of course, that Viola and Jingjing have been speaking about. But okay, so what is that really, that topic? So emissions and removals from standing forests, and see, because sometimes we speak about forest degradation, we speak about removals, we speak about forest management, we speak about sustainable forest management, and it's sometimes hard to really conceptualize and draw the boundaries here. This matrix helps me do this. This is essentially a land use change matrix, where you have on the columns the situation before the change, and in the rows you have the situation after the change, and we put our typical REDD+ activities into that matrix. Deforestation is not what we're speaking about here. That's the most important activity that we have in the REDD+ context now, because that's where most of the emissions are. But new forest growth, so tree planting, is also not part of this. But what this is about is essentially the change from more dense forest to less dense forest, or the change from less dense forest to more dense forest. So the loss of carbon or the gain of carbon in standing forests. We sometimes refer to that as forest degradation, and I refer to it also as standing forest growth in this presentation. So those are two principal carbon fluxes that are important for countries that manage their forest areas and that wish to reduce emissions in one way or another. Countries report on those in the context of the Warsaw Framework under the UNFCCC. Now there's opportunities for showing really the mitigation efforts that countries undertake. There's also opportunities for attracting carbon finance, and countries report, therefore, to the international community on this. Here you see which fluxes they most report on. By far, the most important flux is deforestation. Almost all countries include deforestation in their reporting. Second place is removals from tree planting. AR stands for afforestation, reforestation. It means tree planting, simplifying things. But the topic of this presentation is the orange and the blue. That's degradation, degradation and removals on standing forests. Those are the ones that are slightly less included by countries in their reporting. One of the reasons is that it is tremendously difficult to do that. There's progress though. There's progress, and you see here a timeline. No years on the x-axis, the percentage of countries, including forest degradation and removals from standing forests in their submissions to UNFCCC. And 10 years ago, there were hardly any countries who included these kind of things. No, all of the submissions essentially focused just on deforestation. No, but the fraction really has grown. The more recent years have really seen a lot of focus on forest degradation. A lot of countries were able to include standing forests. So there is a lot of progress, a lot of experience that is accumulating. Yeah, so that's part of the very good news. Why is this important to countries? Well, it's important really because there's a lot of carbon in this. There's a lot of carbon in this, and there are opportunities attached to that. This slide shows simply a global carbon balance, and it shows some of the numbers that we have in there. So the red is emissions from deforestation, now at a global level as an annual average over the last 20 years. It's 4.4 gigatons. It's a lot of carbon. But then look at the green. Removals from standing forests are of the same order of magnitude, even slightly more, according to this publication that we took these numbers from. So there's a lot of carbon in this. And if countries do not have the ability to report on it, then they're essentially leaving something important out, and they're leaving an opportunity on the table. Carbon standards are moving in that direction too. And at the right-hand side, you see here that some of the leading carbon standards, in arch trees, for example, there's not yet opportunities for this. In the VCS standard, there's also really not yet opportunities for this. But in the World Bank's FCPF, yes, removals from standing forests can be included. And the same is also true for the Green Climate Fund program. So there's opportunities here. And this is partly probably one of the reasons for which we see so much progress in countries on this. The picture isn't hugely different with regarding to degradation. This chart shows the percentage of emissions that come from standing forests, from forest degradation in a bunch of countries. And you see here that for some countries, it's way more than half. It's really high portions of the emissions that come from forest degradation. It means there's a lot of carbon in this. And you also see the carbon standards. And you see that all of the leading carbon standards really include opportunities for countries to participate with forest degradation. So a lot of focus on these things, especially more recently during the recent years we see. We recently did a lot of work for undertaking a bit of a methodological review of things, and we tried to boil down estimation methods, the basic approaches for estimating emissions and removals from standing forests, into 3 buckets, which this slide shows to summarize, because there isn't one way. There isn't one methodology that would be agreed between countries, but countries work in different directions. And this slide shows the 3 principal methods at a glance. Most common way is what we refer to as areas and biomass stocks. It means that a country would measure activity data, would measure an area that's undergoing removals or that's undergoing degradation, and it would attach an emission or removal factor to that. You need an area measurement and you need an emission or removal factor. That is a very popular way of doing it. The second bucket that we identified is something we refer to as wood extraction versus regrowth. That requires for the country to have an estimate of cubic meters of timber extracted from the forest, and some sort of CO2 number per cubic meter as an emission factor to attach to that for the losses. And then for the gains, again, there would be a hectare number needed together with a removal factor. Completely different approach, different data sets, also something that countries use. A third approach for doing it is to rely on serial NFIs, National Forest Inventories. We refer to that also as the stock change method, the direct measurement of changes in biomass stocks. Here, we wouldn't have emission factors or activity data. Here, we measure directly because the gains and the losses are measured directly through the differences between repeating National Forest Inventories. There's a lot of complexities attached to this, and Viola has spoken about some of them already at length. I'll very quickly highlight 3 of them, and then I will wrap up. That can maybe help with some of the discussion. One of the difficulties, one of the complexities really is to separate degradation and growth as activities, as events that occur, in the forest that are potentially due to human influence, separating those from naturally occurring variation in the forest. check on the right-hand side. This is meant to be ground covers, tree outlines, essentially. Close to a river, you will have a lot of trees, even in a savanna environment. If you move a bit further away from the river, it will get a bit sparser. Yeah. Now, does that mean that the forest that is just a little bit away from the river is degraded, or does that mean that it's naturally just simply a little bit sparser? How do you handle that when you try to design some sort of remote sensing approach for detecting degraded forest? Very difficult to do. You continuously find yourself in this situation where you have to make a call, whether something that you see is such natural variation or whether you have a signal there, the signal of change there that therefore is reflecting of human intervention of one sort or another. Here's the second complexity. How fast does the standing forest grow? That's something that Jingjing spoke a lot about. Now, he has shown some amazing figures on the bias in what we consider the best available science in the IPCC tables. No, amazing, really. This is related to the availability of national forest inventory data around the world. The situation is improving, and the map here shows that in a lot of countries nowadays, there are full or partial NFIs available. But still, there's data gaps. There's data gaps, and that is related to lack of availability of these NFIs. Sometimes they're not public. Sometimes they are not really designed in order to track growth. No, because to do that properly, you would need permanent sample plots. Very rarely do NFIs in the tropics include permanent sample plots. Often countries are forced to fall back to using those IPCC default factors. Those IPCC default factors, the very same ones that Jingjing really raised some serious doubts about just a few minutes ago in his presentation. So that's another complexity that I'll highlight. Here goes a third one. There's probably a much longer list. Others will surely be interested in contributing to this, but here's my third one. What's the disturbance area? Now, remote sensing is, of course, what we use to identify areas most of the time, yeah, but it's immensely hard to do that. On the left-hand side, you have a picture from 2018. On the right-hand side, you have an image from 2022, 4 years later, and you can see some changes there, no? Some sort of orangish, pink dots. That might be the degradation that is happening here. But what matters isn't only whether a piece of forest is degraded. What matters is whether the change that brought about that degradation, whether it occurred during the assessment period. Because our measurements in this context refer to specific time periods, which we called the reference periods or the crediting periods of the carbon standards or the reporting context that we use. Here we have a definitional difference between those changes that occur during a period and those changes that occur outside that same period. That area that I'm highlighting here as blue, that might also have undergone some degradation. There might also be a degraded forest, but it's completely irrelevant for reporting purposes, whether or not that forest is degraded, simply because the change did not occur during the assessment period and during the period that we're trying to measure carbon reports for. Okay, that's a third challenge, dealing with time and getting periodicities right and setting the definitions right, not only in an operational way, and some of the colleagues have asked about that in the chat before, but also in a way that is sound, and reflects what broadly happens to the atmosphere. Here's my summary. Emissions removals are incredibly hard to measure in standing forest. Nonetheless, they are increasingly important to countries. This should be saying not important, should be saying, yes. Because of what I said, it's part of carbon standards. There's a lot of carbon in those activities. Emissions and removals from standing forests have grown a lot because of that. What we need is more research, more progress, and especially more country experience on three things. There needs to be more clarity on definitions. They need to be consistent across countries. They need to be operational. And they need to be right. They need to avoid the biases. We need better area estimates. Remote sensing needs to make progress. We need to apply the methods in a more consistent way. And we need better emission and removal factors. Some of the research that we speak about here can contribute to that, of course. And I think it's hugely important. Here go also 2 papers that we've recently published on that. Try click the links. I don't know whether that works on the screen. I'll put them into the chat too, in case anyone is interested. Very glad to follow up. Thank you very much for giving me the opportunity to present here. Robert, back to you, please.
Excellent. Thank you very much for a great presentation. And would be great if indeed you can copy the links in the chat because they're not clickable on the screen. I suggest, since we're running out of time, I suggest any questions and answers, we will just do them in writing, which seems to be working very good anyways. And with that, maybe we move on directly to our next speaker. So it is my pleasure to introduce to you Diego Josué Incer Núñez. Diego is a researcher from the University of Valle de Guatemala, and his expertise is in remote sensing and mapping forest area dynamics. He is supporting the government of Guatemala with RED reporting to the UNFCCC and to the FCPF Carbon Fund. And he's accompanied online by Manuel Custodio, who is a GIS analyst working for Guatemala's INAB, the National Institute for Forests. So Manuel will be available online for answering any questions, which you could actually also directly write in Spanish, would be preferred, but otherwise you could do it in English. So with that, Diego, the floor is yours.
Thank you for presentation, Marieke. Listo. Good morning and good afternoon. I hope in these 10 minutes, I hope to share with you what Guatemala has achieved in the area of degradation and recovery for degradation. In Guatemala has several milestones in the reporting of greenhouse gases since the 2000, and the importance of these national reports is that in the last 3 national reports, Guatemala made an effort to align the carbon accounting because the first and the second communication were not aligned by the method. And we in this milestone is a national level, but in the red context, Guatemala has an important milestone for accounting timeline because Guatemala has a national red strategy that has the 2020-2015 the period covers, and also Guatemala has an emission reduction program under the Forest Carbon Partnership that covers 2020-2014. And also Guatemala has a forest emission level. Historical emission covers 2006-2016. And we have a first monitoring report under the forest carbon ship that covers the years 2020. And the last months, Guatemala works in the draft of Red Technical Annex that maybe Guatemala can propose presenting the future BTR, and this is the important milestone that Guatemala has in the carbon context in national level and the red context. And also, it's important to tell you the elements that Guatemala has to have a national carbon accounting. We have a forest definition that is a link to the FAO definition, and we have a protocol where we find the categories of land use to use collector to collect the activity data, and we have a grid of points that is more than 11,000, and we use a collector to collect information, and we are homogeneize the criteria for deforestation, degradation, and carbon enhancement. We have a interpretation for quality data to control the quality data, and we have all the territory. We have 4 red activities, that is deforestation, forest degradation, recovery from forest degradation, and carbon increase through forest plantation. We have defined the carbon pools included in the carbon accounting that is above ground biomass, below ground biomass, and dead organic matter and soil carbon. We don't accounting. Our reference levels cover a few more years. Our reference levels cover about more than 10 years. We have an initial year that is 2006, and the final year is 2016. And from 2016, Guatemala implemented mitigation actions that is in the framework of the REPTA strategy. And finally, we have a carbon contents for emission and removal factors. We have a carbon strata map that has four categories of carbon, forest carbon. We use IPCC default non-forest carbon contents, and we have models for carbon removals in forest plantation. In the picture that you see in the left is the point, a grid of points that is about more than 11,000 points. And the picture of the right is the carbon strata map that has four categories of forest carbon. And the method that we use for calculation and emission and removals in Guatemala is the general formula for calculation for emission and observations from Guatemala, which is also used to apply the Monte Carlo model in simulation. We have an activity data, and we have the emission factors and removal factors. In Guatemala, we use a first approach of degradation. We use a first approach because during the stage of the validation and verification of the subnational reference level, which is under the Forest Carbon Partnership, we use a approach that is we identify the plot is considered a forest permanence. And when we identify if the plot is forest, we assign a forest strata map according to the carbon strata map. In the first approach, we use a approach that we identify if the degradation it was when the forest lost his element trees that between 30% and 60% of the tree element. If the plot lost this range of percentage, we assume that the forest the plot is degradation, and we use a discount of 50% of the carbon loss was discounted compared to year one. And the opposed case, in the approach to post-degradation recovery, we identify first if the forest is a permanent. One of the forest strata was assigned to the plot according to the carbon strata map. And in the same case, if the plot gained between 30 and 70% of the true elements, we assign a gain of 50% of the carbon content was applied to year one. And we use in this picture, you can see the example in the forest degradation. We saw in the 2006, we saw the plot have entire 25 elements of tree. And in the 2016, we saw that the elements of trees was 10 trees, 10 elements of trees, and he lost the plot lost 15 lost elements of trees, and this passed to grassland. But the plot is also is considered a forest, because we in Guatemala, if the forest has more than 8 elements trees, is considered forest. And in this case, the plot has a 87 tons of carbon, and the equivalent of the loss of this initial year was 43 tons of carbon, and we applied this data for the degradation accounting. In the case of recovered degradation, we saw in 2006 that the plot has 12 points of truth, and in 2016, the plot recovered the totality of the 25 plots in the 2006, and we are seeing the equivalent of the gain of the 50% of 115,000 carbon per hectare. This is another example. We see the opposite of the case of degradation, and this is how is the first approach applied in the carbon accounting in Guatemala. But in the stage of the validation and verification auditory, the auditors wants to Guatemala detail the definition and degradation approach, and Guatemala works in this second approach, and the implication in the general accounting. For the degradation, we established three category of gradientes for conservative to degraded forests are established in primary forest, degraded forest, and highly degraded forest. This categorization is done based on the direct relationship between the number of tree elements and the plot that plot has and the average carbon of the carbon strata map. In Guatemala, from 8 tree elements to 25 tree elements, the plot is considered forest, and based of the conservation category, a carbon content is assigned. To quantify the degradation is done quantify the number of tree elements that lost between year 1 and year 2. And the most important of this approach was also used for deforestation. So instead of the plot losing all this carbon, the quantification was made on the relative loss of the trees that the plot lost. And the same way, in the recovery for degradation, we are seeing three category of conservation categories: primary, degraded, and highly degraded. And the difference with that occurs in the degradation, we are seeing gained carbon accounting. And how we apply this for the more than 11,000 plots, we use this decision matrix that we saw the initial observation with the elements that are trees, and his status is primary, degraded, very degraded, and the carbon content in the way that the elements trees that has the plot, and how we assign the range of degradation. We saw in the left that we have a table that if the plot has 20 to 25 tree elements, we assign primary. If we have 14 to 19 plots of elements trees, we assign degraded plot. And if we have 8 to 13 very plots of elements trees, we assign very degraded. And if we saw the plot pass to primary to degraded, we only assigned the elements, the carbon of for the carbon content, if the plot if the plot lost 3 elements, we are seeing the relative of 3 elements covers 3 elements carbon content, and it represents like maybe 6.9 tons of carbon that the plots lost. And this second approach is important because we apply the same way for the deforestation, which allows for the consistency for in the calculation and emission and removals. And we see the three gradients of the initial observation for year one and three gradients of year two. And this table represents the theory of how we assign the carbon content for each of the plots that we have defined as degradation and recovery of forest degradation. And we see the same examples that we see before. And this approach is more conservative. Look, is because we only assign the relative carbon that the plot loss and assign the relative carbon content that the tree gained. And how this approach is so in the calculation, in the emission and removals mitigation result of the red activities, we saw that the first approach we have like 13 millions of tons of emissions. In deforestation, we have 12 millions of emissions. And the degradation, we have 4.2 millions of emissions. And degradation, we have gain, 2 millions of emissions. But in the second approach, you can see the difference between the first and the second. We have a significant minus deforestation. The degradation is like 1 million less. And recovered from degradation, we saw that the difference is not significant. And for the monitoring of national level with a second approach, we saw the deforestation we have a lot of degradation recovered that is Guatemala demonstrate that if in the implementation in the period of the implementations activities mitigation, we saw that Guatemala has enough results to have a good national reduction of emissions that potentially we need to we need to we will work to demonstrate that the activity mitigation has generate reductions emissions. But in Guatemala have needs to strengthen what we need to strengthen the approach. We need to use the National Forest Inventory, the permanent monitoring plots and other studies to have verify the correlation between the forest conservation forest categories, and we need to give the integration of national forest inventory to the activity data for sample and for sample-based area estimation of Guatemala, because we need to use field information to correlationship the data that we have collecting the collector, the mesh. We need to do statistics for the emission and forest degradation and recovery for the degradation, because we need to apply the Monte Carlo model to emission factors and removal factors, because we know that degradation and the degradation of emission factors and recovery degradation contribute a high percentage of the total uncertainty of emissions. And we need to improve our national standard operation procedures to improve our quality methods to ensure the quality of the data, because we need to guarantees the quality of the information, and we need to we focus in the statistical information of the emission factor because we saw in the recent reports that we need to improve this data because Guatemala maybe can discount in the incertidumbres accounting and we need to improve this statistical data use use the national forest inventory and we have some challenge for Guatemala in the way of the degradation and recover degradation. We need to strengthen the national forest inventory to measure all the classes and the status from degraded to conservative forest. We need to stratification and sampling intensity. We need to improve the design of the national forest inventory to align the data grid that we use in the carbon accounting to respond to deforestation and degradation areas and the main areas that Guatemala has to 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 align the programs that Guatemala has for the forest restoration and plantations and the REC projects. We need to analyze the forest permanent monitoring plots in national forests and forest plantation to generate the removal factors because Guatemala don't have removal factors for natural forest. We need to activate the permanent monitoring plots, the network for natural forests and increase the plots of the plantation. We need we need to analyze the national information of fire scars caused by forest fires and the relationship with the degradation and the deforestation and degradation. We need to generate information for the recovery areas for non-forest to natural forest because we see that it is important national red activity. We need to consolidate and nationalize the national forest monitoring system in Guatemala to establish the roles and functions in the long term for the generation of the information for carbon accounting. We hope that the next cycle of national forests we are able to add variables to improve the measure for forest degradation and in a more formal way. And Guatemala must work in the development of the safeguard system to ensure they respect during implementation of RED actions to halt the degradation and deforestation. And finally, this is a team effort between government institutions, academia, and international cooperation agencies that have supported us in improving Guatemala in carbon accounting. And we hope that in the short and the medium term, these efforts can be reflected in Guatemala access to the potential climate finances. And muchas gracias. Thank you very much for your attention.
Thank you, Diego. That was great. Thank you. Thank you. I think in the interest of time, we'll also have questions in the chat. So if you can, when you see questions that people have written in the chat, maybe you can address those. And so let's get some feedback. Let's hear what everyone thought. Let's see. Daniela, do you have the next group of interactive questions that'll sort of let people reflect on the last couple talks? This would be group 3, I think. Okay, well, we just heard some good examples of challenges and strategies in assessing degradation or emission removals in your area of interest. What strategies have you used? This is just an open-ended word cloud. And Madison, while people are talking here, you mentioned that the poll can be accessed there. Does that live on after this call so that we can see the final results of all the Slido questions?
We will be able to see the real results and we can share that later in a report. The actual poll should be closed as it progresses through live as for participants being able to take it.
Okay. Okay. But we'll be able to see to share the final answers to some of these things if people are interested.
Yes.
Okay. Well, this is a tough one to come up with simple one-word answers for. Let's see, what do we have here? Data. Yes. Quite a range of different options here, and all about the same. Let's see if we can do some aggregating on the fly here. Definitions. Definitions comes up several times, as we might expect. Anthropogenic versus natural disturbance effects. That's something we haven't really touched on here too much, but that's obviously really critical. Data sources. Presumably that's a challenge. And data from the field, yes. Defining degradation.
Oh, decoupling anthropogenesis versus natural disturbances. That's a good one as well.
Yeah. Temporal gaps in data. Yes, that's it. Especially when we're looking at a phenomenon like growth, where, as Till said, timing is of the essence, knowing, well, for all of these. Oh, we've moved on. Oh, okay. Financial and technical difficulties with satellite data acquisition. Yes, that's a good point. And Jingjing, we've got some artificial intelligence and machine learning here for you. Well, this is quite diverse. Thank you, everyone. But it does seem like, in some ways, our usual suspects of the definitional challenges, acquisition of data, and then some specific, sort of other variants on that, really. Transparency, though, that's a very good point as well, making sure that all of the data that's collected is transparent, and that can be a challenge. Thank you to those. I recognize that we're running a little late now, so if you have to leave, as I'm just seeing a couple messages, thank you all for joining. We're going to keep going here. Don't leave, but certainly appreciate everyone weighing in. Why don't we move on to the next one, Daniela? So the question here focuses on ground measurements and whether you're using those repeated ground measurements and reporting degradation or regrowth. This is a simple yes or no. Hmm. Well, this is I don't know, Marieke, what's your thought on this? This seems actually quite encouraging, or Till.
Yeah, I had expected more no's, to be honest, because it's so challenging for countries to use those repeated ground measurements. First of all, to have them, and then also to be able to use them. So, no, this is really interesting to see.
Yeah, yeah, for sure. Thank you, everyone. Okay, well, I think we're slowing down, looks like. So maybe we'll go on to the next question. If you are using those repeat measurements, what challenges and successes have you found? And if you are not, what change would need to happen? What would need to occur for you to be able to use those repeated measurements? So in your response, this is open-ended, but maybe you can say yes or no so that we know which part you're responding to. Cost, for sure. Okay.
And the need of permanent sample plots. It also made me wonder because obviously we have a mixed audience, right? So we have researchers who often do have permanent sample plots, and we have countries who often lack it. So
I like
curious.
anonymous, heartfelt yes and no. That's speaking to the challenges in all of this. Yeah, and remote areas access for sure. Yeah. And I'm assuming that the follow-up and support for consolidation of national processes is somewhat about the human element and the policy element and the politics, I imagine, of trying to get everyone using same methods, which, if that were the case, is definitely an important component. Hmm. Okay, we've got a couple more people typing. Okay. Lack of funding, technical capacity. Yep. So a lot of similar themes throughout several of these polls. One more person typing. I think this is the last of our third group here, and then we have that last little group of sort of overarching questions. Let's thank again Diego and Till for their presentation. Thank you both. And if you can hold on a little bit for our discussion, a couple minutes, we'll come back to that. And then Daniela, do we have group 4? And then Marieke can take over there.
Yeah, thank you. And as Danielle is pulling out the slides, let me also say a heartfelt thank you to Madison, Ziegler, and Daniela Requeña for all their support behind the scenes on this webinar. So here we have, all right, here we have the, oh, it's gone again. Okay, that was the question, but we need the Slido maybe. Let's see. So wait, maybe I can read out the question in the meantime so you can start thinking about the how to answer it in the Slido. So right now, what we have in the carbon standards like R3s and VCS JNR, removals from degraded forest happening on degraded forest lands are not covered by these carbon standards. So what is the implication of that? So you know that it's currently under those standards, you cannot report any emission reductions or get any payments for carbon credits. What are the implications for your country or work area? Is that a major limitation, or would you say like, well, we don't have that data anyways, or maybe is it really important, or you're like, well, the most of the emission reductions come from deforestation anyways. Oh, hey, how's this?
It doesn't look right, right?
Okay,
Let
it
me
looks a
try
bit
again.
strange. Let's see. It's a new Slido, right, Daniela? Right.
Marieke, I don't know if you have the question there in a digital format that you could just paste it into the chat while people are waiting.
That's a good one. I don't, but I can type it out. So, or maybe we could also, if the Slido is not working or if it's too complicated, we could also just have that discussion here. Oh, there we go. Till, thank you. Right. So he has it here written out. So Yeah, we're just curious, especially from the countries. Obviously, the researchers in the room are not they're supporting the countries perhaps, but they're not like themselves submitting to carbon standards. But for the countries that are present here, is it really a priority to find a solution that carbon standards would cover this, and that you could get carbon credits for emission reductions from, restoring degraded forest? Or is it not like your top priority right now because the monitoring might in any case be very costly? Diego, how about I put you on the spot for this one? What would you think for Guatemala? So for Guatemala, would it, of course, you're participating right now in the FCPF Carbon Fund, and reporting to the UNFCCC. So in that sense, emission reductions from removals on standing forest, they can be included. But in case Guatemala would be interested to move to our trees, for example, the fact that currently you cannot report emission reductions from removals on standing forests, is that a big limitation would that be a big limitation for Guatemala?
I think it's a challenge because we know that Guatemala has a transition for non-forest to forest that we need to study if we can include it in our trees, because we think we have this red activity potential, and we need to work that if Guatemala can be include this activity in trees.
So for Guatemala, it would be important to get it covered eventually.
Yes, because we think that this activity we can support reductions of the emissions in Guatemala. We think this is very important activity for Guatemala.
Thank you for that feedback. I think it must also be important for other countries as well. Thank you, Daniela, for meanwhile, we've got the Slido on the screen. There's another country where it's not a priority at the moment. We still have challenge to assess significance, and if found to be significant, include the activity of degradation for all Brazilian biomes. So for Brazil, not the top priority in a country. Okay, maybe people can also get the answers in the poll in the meantime. So the first person managed to get there. So right now we have two of two saying it is important, and now we have 50-50. So three with a major importance, and 3 where it potentially could be important, but the data currently isn't. I guess it's difficult to answer this one, right? Because for a lot of countries, I guess it could be important, but the data is not ready to submit it. Interesting. So yes, this is kind of not really surprising, right? So a lot of countries, they feel it is important, but the information isn't yet sufficiently accurate. Excellent. So maybe we want to move to the final poll question. All right, so the final poll question, it gets back to the GFOI methods and guidance document. So first question is, are you familiar with it? And the second part of the question is, do you think it provides sufficient guidance on assessing degradation and regrowth? So, not everybody is familiar with it. Let's provide the link to the methods and guidance document in the chat as well. So let me go look it up.
Thanks, Madison.
Excellent. And Diego, meanwhile, to answer your question, yeah, so currently recovery of after degradation, it's only included like as a net of degradation emission factor, but there's no the current standalone standards, so not counting the pilots like the FCPF Carbon Fund or the GCF window, which is a results-based payment, not really a carbon credit. It's currently not covered, at least in the jurisdictional standards. We're not covering projects here. Great, interesting. I didn't expect so many people not to be familiar with the methods and guidance document. And nobody actually, oh no, there is somebody who thought it was well covered. I read it wrong for a second. But most people like to see more guidance there. Right, so we're heading towards the end of the hour. Robert, maybe we can wrap it up.
Yeah.
Did you want to say something to conclude, or shall I share my concluding thoughts?
Well, I will just briefly say thank you to everyone. Certainly, this has been informative for me, not to just look at it through my own lens, but I really do appreciate everyone leaning in. I think some of the results we found, the stories we've heard from our presenters corroborate things we've known, and then I've also certainly learned a bunch of new things. And thank you all to our presenters. I noticed we do have a hand up, or did that hand go away? I didn't catch who that was. But anyway, thank you all. I'll hand it back to you, Marieke.
Thank you. And yeah, I love how we try to make here the connection between the research and the countries. And I think we've all taken note about certain challenges. Finance is a challenge. I'm not sure research can fix that, but definitely we see that uncertainties, data uncertainties, methodologies, all of this was mentioned very prominently. So let's try and see that that the research helps the countries, that altogether we manage to get in the right direction. So the challenges are just many, especially with these fluxes like removals and degradation on standing forest. So we're seeing also artificial intelligence coming in and playing a role. So let's see what comes ahead, and let's see if the research can help countries to reduce the uncertainties around these estimates of the important fluxes. And eventually, when we are more solid about all this data, it can be used beyond just reporting to the UNFCCC, but also in carbon standards to actually create financial incentives for carbon credits for countries. So thank you everybody for contributing to this exchange. We hope it continues. We hope this was an opening. We met each other. Please feel free to reach out to the panelists, to us. We love to keep exchanging. And I have no mandate on suggesting that the MGT should be rewritten, but note was taken that there is an interest in more guidance on removals and emissions. All right, thank you everybody. Have a wonderful day, a wonderful evening, and yeah, see you in the next research and development series with the GFOI.